the user now has this all-powerful God token on the device. They, local apps on the phone can start syncing, but somewhere we want to get the browser involved. So there's a technique here that we actually already use on Android phones today. So unrelated to all the strong authentication, on newer model Android phones, ones that are pre-ice cream sandwich, whatever that release was called. When you turn on your phone, it asks you to log into your Google account, you type your username and password, or you might do an OAuth dance if you're a SAM authenticated user. The end result is your phone ends up with one of these God-level OAuth tokens. And so that part actually already works today. The very first time you launch your browser on that phone, the operating system and software in the mobile browser, what it actually does is it looks in the browser and says, oh well, first time it's ever being launched. It goes and takes this God-level OAuth token, and it uses it to make a call back to Google and says, Google, I'm about to launch a browser for this user. Here's this God-level token for this user. Can you give me a blob I can use to initialize the user's browser? What then happens is the browser just opens a very specific URL to Google, takes this blob and puts it as a URL parameter. Google's web servers, they get this blob, they look at it and validate it and say, oh wow, this was a request to issue a session cookie in this browser for this user, and so we actually automatically log the user in. So like I say, if you have a recent Android phone, you'll find that part already works. So it's always a question of how to bootstrap getting the God-level OAuth token on the phone, but once it's there, at least on Android phones, and there's nothing specific to Android about it, you can do it on other phones. You can then get the user automatically logged into the web browser simply by opening a very specific URL. So it didn't require, honestly, much coding in the browser, just a small amount. So one of the key things to note here is we're trying to create this cookie process to track how was the user authenticated on this device. So when the God-level token was first issued to the phone, we actually, as Google, we know that we issued it because MobileX provided half the token and the user typed the PIN. So we actually put a little metadata in that God-level token that says it was issued because MobileX was involved in the process. Now here, the user is trying to open their browser. Again, they take this God-level token, they go to Google, they ask Google, hey, we want to cause the user to be logged in the browser. Great. Well, again, this token with this metadata comes back to us that says MobileX bootstrapped it. So when we issue a session cookie in the user's browser, we actually keep that breadcrumb in there. We actually keep how the user was authenticated. We say it was done by MobileX, plus a PIN. So that information is now sitting on Google.com. So now finally, the user's in their browser, they're logged into the identifier, they're strongly authenticated there. Now finally the user goes and visits a relying party, in a browser, say on a mobile device. So medclinic.org, they go there, they click sign in, they choose their account. They now get bounced to their relationship provider, identifier, whatever you want to call it, but they get bounced to Google. And Google, if the user hasn't already consented to share information, will need to ask the user, do they want to? Assuming the user says yes, now it's back to Pam's code. It's standard OpenID Connect as a response back to the relying party. The relying party now can get the email address for the user through the user info endpoint, but it can now do some other things. If MedClinic asked for the scope for reading the user's street address, well great, in the previous session we just showed how that would work. They get access to a list of street addresses for the user. If they see one they like, they can ask Google for a token from Google that they can then use to go to the attribute provider and pay to get the user's verified address. So maybe MedClinic notes that the attribute provider for this user is MobileX. They go to MobileX, they get the verified street address, they pull MobileX. Great, now MedClinic knows who the user is. But there's another thing that can happen here, and I really should have made a copy of Pam's slides. She showed that there were two endpoints, the user info endpoint, basic information on the user, but the other one was the session endpoint, right? That's designed to actually do the login and the logout. And we talked about there, who remembers the ISO code because we got it wrong? 29. Yes, so, in a perfect world where no one needed to make money, the Google identifier could just, right in there, pass an assertion back to the relying party saying, this user was authenticated, in whatever is the right scheme that matches that ISO, but it was, based on an unphishable certificate in combination with PIN. Google could pass that information back via OpenID Connect. Our suggestion is we wouldn't pass that information back. Instead, during this OpenID Connect flow with MedClinic, MedClinic would get that token. They could go to Google's session info endpoint, But if they wanted to verify how the user was authenticated, we would tell them, oh, you want to find that answer out? Great, user's authentication provider is MobileX, and here is a blob you can use to send to MobileX. Now, before we do that on our side, again, following this breadcrumb, we know on this browser the user was authenticated by MobileX plus a PIN. So, when this OpenID Connect, request comes into our session info endpoint, we're still keeping that breadcrumb. Now the breadcrumb's in the OpenID Connect token. It finally comes back to Google, and Google will return a token to MedClinic saying, okay, here you go, here's a token, send it over to MobileX. Finally, MedClinic can send it on to MobileX. Sorry, I skipped that one. And MobileX now has to rip apart the token. And in the previous session, we showed this list of like 7 things it has to do to validate where it came from, does it have a billing relationship, etc. But now there's one additional thing it has to check. It actually has to look in the token that Google produced, for that session that comes all the way back to MobileX. And this is actually information from Google to MobileX, to try to finish the full loop of the breadcrumb, where we say, hey, MobileX, you helped us, start this session, maybe at this date, maybe in this time, maybe based on this other information. All of that data comes back to MobileX, and MobileX now can, if they have a billing relationship with their line party, they can give a response back to their line party saying, yep, I assert that I strongly authenticated this user at level X, Y, Z. Okay? So that's how we're trying to finish the whole process at the end. So as I sort of mentioned before, in the perfect world, if we didn't need to make money, there are simpler ways of passing this information via OpenID Connect. In the user info, you can pass street address. In the session info, you can pass how the user is verified. But that assumes that there's one vendor who does everything, who does consent, who does identity verification, who does strong authentication. In an enterprise context, that's traditionally true. In the consumer context, we're suggesting that, unfortunately, it's going to be a little bit more complicated. The relying parties are going to have to do a little bit more work, go technically to get this information, and they're going to have to pay for it. But the end goal is to show that we actually believe that mobile carriers can make significant additional revenue by acting as a user's street identity attribute provider and authentication provider in this model, and can actually provide session-specific information about how a user is authenticated. So that